In level 3, we'll be finding the surface area and volume of prisms. We will also be using various formulas to find the surface area and volume of other three-dimensional figures like spheres and cones, and you'll always be given the formulas for those. But for a prism, you would never be given the formula on the ACT, so we're not giving you formulas. So let's talk about what a prism is. A prism is a three-dimensional object that has two parallel bases that are congruent figures. So if we look at this first figure, this pentagon, which shows up twice, those are the bases. So that's the base, and it has another base. So two parallel bases. And then the line connecting it is the height. This next one is a hexagonal prism. It has two congruent hexagons that are parallel. Those are the bases. And the height connects them, and it's perpendicular to the bases. And then we have a triangular prism. It has two congruent triangles for the bases. And then we have the line connecting them that's perpendicular to them is the height. And for any prism, if you're finding the volume, you always do the area of the base times the height. So, for example, a triangular prism, we would find the area of that triangle and then multiply by the height. For surface area, you're just going to find the area of the rectangles that make it up and the other shapes, whatever the bases are, and then you add up all the sides. So let's look at some examples. For the surface area of this triangular prism, we need to do the area of each of the sides that make it up, and we add them all up. So for the surface area, I need to think about what this figure is made up of. This figure is made up of two triangles, here and here, and they're identical. So I've got triangle, triangle, and then we have three rectangles. The rectangle on the top, we have a rectangle at the back, and then we have a rectangle on the bottom. So we have three rectangles, and we want to find the area of all of those figures. So let me erase. So let's start with the triangles. If I wanted to find the area of one of those triangles, I need to do 1/2 base times height. And it should be labeled that this is a right angle. But this is a right triangle, and so the base and height would be 3 and 4. So the area of this triangle is 1/2 times 3 times 4, which is 6. And in a prism, the bases are always congruent, so if the area of that first triangle was 6, the second one is also going to be 6. Same thing. Now I want to find the area of all the rectangles. So if I start with the top rectangle, I'm actually missing the length of this side right here. But I can use my right triangle knowledge to find that length. I can do Pythagorean theorem. If I know my Pythagorean triples, I might know that this is a 3, 4, 5 triangle. Or I could do Pythagorean theorem, 3 squared plus 4 squared equals c squared, and you would get 5 for that missing side. So for the area of this top rectangle, I'm going to do 5 times 11, length times width. And we get 55. Next, I'm going to do this back rectangle, which is 3 by the height of the figure, which is 11. 3 times 11 is 33. And lastly, I need to do the bottom rectangle, which is 4 times 11. We get 44. And then we add up all the areas of those 5 sides, and you get 144. So So the surface area is 144 centimeters squared. And then for volume, we kind of already talked about how to find the volume of a prism, but we always do the area of the base times the height of the prism. So let's write our volume formula. Area of base times height. Now remember, the height is or the base is the two congruent figures, so those triangles are the bases of the prism. The height is the line connecting them. So 11 is our height. So for the area of the base, we're finding the area of that triangle, which is 1/2. We said that this was a right angle, so 1/2 times 3 times 4. And then the height of the figure is 11. So we get, that came out to 6 times 11, which is 66. So 66, and volume is always cubic centimeters. In this next example, we're finding the surface area and volume of a cone. For weird figures like cones and spheres, you'll always be given formulas. The ACT would give you the formula, but you do have to know what the variables mean. In a cone, you have two different heights. You have the regular height, which we call h, and then you also have something called the slant height, which is the height of the slanted part. And sometimes you use the variable s, and sometimes you see it as an L. But in this case, we have an S. So to find the surface area, we're just going to follow this formula, pi rs plus pi r squared. So for surface area, we need the slant height. And in this cone, we are given the slant height, that's 10. So for surface area, we are going to do pi times 6, the radius, times the slant height, which is 10, plus pi r squared. So pi times 6 squared. And this gives us 60 pi plus 36 pi, which adds up to 96 pi. So we get a surface area of 96 pi, and this is in inches, so square inches. Now for the volume, we are using the formula 1/3 pi r squared h. So this time we need the regular height, which is from the top of the cone straight down to the middle of to the center of the circle. And in this case, we weren't given the regular height. But the slant height, the radius, and the regular height make a right triangle. So using that right triangle, we can find the regular height with Pythagorean theorem. So I've got this right triangle, bottom 6, hypotenuse 10, and I use Pythagorean theorem. Let's call this h. 6 squared plus h squared equals 10 squared. We get 36 plus h squared equals 100. Subtract 36 from both sides, h squared equals 64. Square root that and you get h equals 8. And you might have recognized the 6, 8, 10 Pythagorean triple. But so we get 8 for the height of the cone. And now we plug that into the formula. So 1/3 pi times the radius squared, so times 6 squared, times the height, which is 8. And just like before, we want to multiply the number of parts, but we don't forget the pi, but we don't actually compute that part to keep it in an exact form. 1/3 times 6 times 8 is 96, and don't forget pi. So we get 96 pi for the volume. So In this case, the volume and surface area ended up being the same answer, but that's just a coincidence.